Picture this: warm, gooey chocolate chip cookies straight from the oven, crunchy candies, velvety cakes, waffle cones piled astronomically high with ice cream. Is your mouth watering just a little bit? Are you already craving dessert? Well, welcome to this explainer. Today, we aren't just talking about our sweet tooth. We're taking a total biological deep dive into exactly what sugar does to our bodies and, crucially, our brains. So it's a totally universal question, right? Why is sugar so incredibly hard to resist? And the truth is, it's really not just a matter of willpower. Sugar is hiding absolutely everywhere. I mean, sure, we expect it in candies and desserts, but it's also packed into tomato sauce, yogurt, granola bars, you name it. Because it's so incredibly pervasive in our modern diet, understanding its effect on our brain is absolutely vital for our health. All right, well, let's take a quick look at our roadmap for this explainer. We're covering 5 key areas. First, the brain's sugar addiction. Second, the anatomy of a sugar rush. Third, the overload effect. Fourth, the timeline of quitting sugar. And finally, number 5, exercise, the ultimate antidote. We're going to explore both the biological problem of sugar overload and its empowering solution. Let's kick things off with section 1, the brain's sugar addiction, and exactly how dopamine drives our sweet tooth. Think about the very second you take a bite of cake. Sweet taste receptors on your tongue immediately fire signals straight up to your brain. This triggers the release of dopamine, a vital chemical neurotransmitter that basically acts as the major currency of our brain's reward system. It helps answer a single subconscious question: should I do that again? When dopamine creates that warm, fuzzy feeling after you eat grandma's chocolate cake, it's reinforcing positive behaviors. But unfortunately, it's also setting the very foundation for intense cravings. To put that into perspective, imagine a balanced meal of broccoli versus a sugary donut. If you eat the broccoli, your dopamine levels spike initially but actually level out over the next few days. Your brain literally does this to make the food seem kind of boring, so you'll go seek out other varied nutrients. But the sugar? It completely bypasses this natural leveling out process. No matter how often you eat it, the dopamine response doesn't drop. It continuously feels rewarding, acting a little bit like a drug in the brain. Moving right along to section 2, the anatomy of a sugar rush. We'll be following sugar from the tongue straight into the bloodstream. All right, let's meet sucrose, good old-fashioned table sugar. It's a simple carbohydrate, a disaccharide, made of exactly one glucose molecule bonded to one fructose molecule. The absolutely crucial point here is that the glucose from a sugary cookie is structurally identical to the glucose derived from kale. Seriously, your body doesn't have a microscopic police force that bans cookie glucose and rewards kale glucose. It just doesn't know the difference. The whole issue is entirely about how quickly that molecule breaks down and enters your system. Let's track this digestion journey. It starts in the mouth, where saliva begins the breakdown. Then it moves to the stomach, mixing with acids. Next, it hits the small intestine, where specific enzymes like sucrase cleave the sucrose into those individual glucose and fructose molecules. And finally, it rapidly enters the bloodstream, where the liver converts the fructose into glucose. Because table sugar is a simple carbohydrate, this entire process happens incredibly fast compared to digesting complex starches. The sheer speed is exactly what causes that notorious rapid spike and subsequent crash in your blood sugar. And that brings us to section 3, the overload effect. What actually happens when our biological tanks are completely full? The core problem with refined sugar is that it gives us empty calories without any fiber, meaning we can consume massive amounts of it without ever feeling naturally full. Think of your liver and skeletal muscles as biological gas tanks for storing all this glucose. The liver can hold about 100 grams, and skeletal muscles hold roughly 450 grams. But once those strict limits are hit, your pancreas releases insulin, and all that excess glucose goes straight into your adipose tissue, your body fat. And unlike your muscles, your fat cells have an essentially unlimited overflow capacity. Okay, but what if we hit the brakes? That brings us to section 4, the timeline of quitting sugar, looking at both the physical withdrawal and the long-term payoffs. In the very first 24 hours of cutting out sugar, your body has to rely on its stored glycogen reserves for energy. And here's where this fascinating number comes in: 3. For every single gram of glycogen stored in your body, it's bound to exactly 3 grams of water. So, as your body breaks down glycogen for energy, it releases that water. This is exactly why you experience a rapid, highly noticeable loss of water weight right off the bat. It's a wild ride. You might face early exhaustion and even metallic breath around day 2 or 3 as your body switches to burning fat into ketones, which is just your body's backup fuel. But stick with it past those cravings, because by week 6, the benefits completely explode. Your digestion regulates, bloating vanishes, and IBS symptoms can drastically decrease. By 1 year out, you're looking at improved sleep, significantly healthier skin with way less acne, and a vastly reduced risk of heart disease and type 2 diabetes. Now, I want to pause and bust a huge myth right here. You've probably seen pop science headlines claiming sugar is more addictive than cocaine. Well, those headlines are actually based on isolated rat studies. While you might feel genuine fatigue and cravings around day 2 of quitting, scientists agree there is no evidence that in humans, sugar can be as addictive as hard drugs. So please, don't let the fear-mongering discourage you. The withdrawal is entirely manageable. Which leads us perfectly into our final stop, Section 5, Exercise, the ultimate antidote, and how it literally changes how our bodies process glucose. Here is the truly empowering solution. You don't have to demonize your favorite treats forever. When you move consistently, your body literally rewires its internal machinery. You physically build bigger biological gas tanks, increasing your resting glycogen storage capacity by 20 to 30%. Plus, exercise shifts your skeletal muscles to preferentially burn carbohydrates, and it highly sensitizes your muscles to insulin. Basically, this means active bodies can safely store and process significantly more carbohydrates before they ever turn into fat. This is the sheer magic of exercise in action. Think about a resting muscle for a second. It completely depends on insulin to unlock the cell and pull glucose from the bloodstream. But a working, contracting muscle, it bypasses the need for insulin entirely. It can absorb glucose directly. This is exactly why right after a workout is biologically the absolute best time to indulge in a sugary treat. Your muscles are actively pulling in that glucose to replenish their stores. Ultimately, sugar isn't evil. It's simply fuel. The danger lies entirely in the massive dose we're often given, the lack of dietary fiber accompanying it, and an inactive lifestyle. A balanced diet of whole foods easily makes room for occasional sugar, especially if you're physically active and your biological gas tanks are primed and ready to use it. So glucose isn't poison, but context is absolutely everything. We've seen how a sedentary lifestyle lets sugar overflow into fat, while an active lifestyle turns your muscles into highly efficient glucose-burning engines. So I'll leave you with this to think about. How will you change your body's context today? Will you stop fearing sugar and start optimizing your biological environment through movement? Thank you so much for joining me for this explainer, and I hope this changes the way you look at your next dessert.